Problem number 14, the first thing we want to do is find some trig ratios by hand. You may have some of these memorized. Let's see, the sine ratio for pi over 6. Pi over 6 is 30 degrees. And so I can quickly put on my information. Obviously, the sine ratio is 1/2, opposite over hypotenuse. I can get the 60-degree one as well from this picture. Here's 60 degrees. Sine ratio would be √3 over 2. Pi over 4, I'll need the 45, 90. We've drawn this many times. And the sine ratio is 1 over √2, which we always rationalize to be √2 over 2. Now I want to do sine of negative x. So sine of negative pi over 6. Well, I'll have to draw that down in the fourth quadrant. The reference angle would still be 30 degrees. Which means I'll label my sides the same way. I'll just need to think about the positive and negative. This time I have a negative here, and so the sine ratio comes out -1/2. Let's see, I want to be careful. Let me do the 60-degree one actually drawn out. So that's going to be here where the reference angle is 60 degrees. That would be negative pi over 3. So 1, √3, and 2. This one gets the negative, sine ratio negative √3 over 2. And then for the 45 one, let's see, negative pi over 4 is here. 1, this will be -1 and √2. And so the sine ratio comes out to be -1 over √2. In other words, negative √2 over 2. And of course, you can see what happened. We're supposed to say what the pattern is here. What's the connection between the sine of x and the sine of negative x? And it looks like in all three cases, the second answer was just the negative of the first answer. So sine of negative x came out to be the opposite value, the negative value of sine of x. In problem 15, we want to do a similar task here. So now we're doing the same investigation for cosine. Let's quickly draw those same pictures. If I'm dealing with 30 degrees, 1, √3, and 2, cosine is adjacent over hypotenuse, so that'd be √3 over 2. If I fill in the 60 degrees here, my adjacent over hypotenuse turns out to be 1/2. 45, 90, that's the same picture we drew and the same answer. Adjacent over hypotenuse is still 1 over √2, which becomes √2 over 2. So is the same thing going to happen? Are we just going to get those opposite values? Well, let's test it out here. So cosine of negative 30 degrees, that would be down here, reference angle of 30 still. 1, √3, and 2. The 1 gets a negative. Now cosine is adjacent over hypotenuse, and the adjacent is positive √3. The hypotenuse is positive 2, so there is no sign change. I get exactly the same thing. How about the one with 60 degrees, the one at the end? Negative 60 would be down here, reference angle of 60. 1, negative √3, and 2. Again, adjacent over hypotenuse is unchanged. And if I try it for the 45, the same thing happens. Only the vertical leg is negative. And so when I do adjacent over hypotenuse, it's the same thing we had before. It's √2 over 2. So for cosine, the relationship between those two items is that they're exactly the same. Cosine of negative x and cosine x, same exact answer. And then in number 16, we're given a relationship. A squared plus 4 equals b squared. And in each of the three problems, we're given a value of a and asked to find the value of b. So first one, a is -4. Let's plug -4 in here for a, and we want to solve for the b. That's going to be 16 plus 4 is 20. I have b squared equals 20. I'll square root each side. This is where the plus or minus comes in, but in this particular one, I'm actually told that b is negative. So I know then to select the negative here. All I need to do now is simplify. I'm keeping the negative. 4 goes into 20, so I know a 2 will come out, leaving me with 5 on the inside. And here then is the final answer. B is -2 √5. Okay, let's try the second one. So I'm squaring 2/3 this time and adding 4, and that's equal to b squared. When I square 2/3, I get 4/9. Let's see, to add the 4, I'm going to have to think of 4 as 4 over 1 and then get a common denominator of 9. So that's going to be 36 over 9. And let me flip this around the other way. That gives me b squared is equal to 40 over 9. I'm ready to take square roots now. I have the plus or minus. I look back at the problem though, and this time the b is positive. So I know to choose the plus. All that's left is to simplify. I'm keeping the positive. Square root of 40. Let's see, once again, 4 goes into 40, so I can take that 2 out, leaving me with 10 on the inside. And square root of 9 is 3, and I'm done. Finally, for the last one, I'm squaring negative root 5 over 2 plus 4 equals b squared. Let's see, the negative times a negative will make a positive. Root 5 times root 5 is just 5, and 2 times 2 is 4, so that first fraction squared becomes 5/4. If I want to add 4 to it, again, I'm going to need a common denominator. It's going to be 16 over 4. That gives me b squared is equal to 21/4. I will square root both sides, plus or minus. What am I choosing this time? B is back to being negative, so I'm choosing the minus. And this one doesn't simplify much. My answer is negative. Square root of 21 does not simplify, and square root of 4 is equal to 2. Negative root 21 over 2.